Today, we're pulling back the curtain on the unsung hero of the industrial world, the quality assurance and quality control process. This is all about how we build massive, complex projects safely, correctly, and most importantly, with a mountain of proof to back it all up.
I mean, really think about that. You've got literally millions of parts. How on earth do you guarantee that every single one is exactly what it's supposed to be? Well, the answer isn't just one thing. It's a super detailed, rigorous workflow. It's the paper trail that proves perfection.
So, here's the game plan for today. We're going to start with the master plan, then walk through getting the right materials, putting it all together, testing the heck out of it, and finally, handing over the keys. It's the entire journey, from start to finish. Let's get into it. All right, before anyone even thinks about cutting steel or pulling a cable, you have to set the rules. This is the master plan. It's the foundation for absolutely everything that comes next. It's where we define what perfect actually looks like for this specific project. From a quality standpoint, a project just flows in these logical stages. You start with the design, then you have to approve every single material that comes on site. After that, you build it, you install it, you test it, and then, only then, do you hand it over. Each step is like a link in a chain, and it has to be perfect before you can move to the next one.
Now you gotta understand, these codes you see here, they're not just suggestions. They're the law of the project. Whether it's ASME for piping, API for pumps, or IEC for electrical gear, these are the non-negotiable rulebooks. They set the absolute minimum standard for something to be considered safe and high quality.
Okay, so here we are at our first real active stage. Look, you just can't build a quality product with junk materials. This stage is all about being the gatekeeper, making sure every nut, bolt, pipe, and panel is certified, traceable, and exactly what the design demands before it ever touches the construction site. This part is basically detective work. First, you submit a material approval request, the MAR, to get the official okay. Then you dig into the mill test certificates, or MTCs. These are like birth certificates for steel, proving its exact chemical makeup. You're cross-checking heat numbers so you can trace a single piece of steel all the way back to the furnace it came from. That level of traceability is everything. All right, we've got our approved materials. Now it's time to actually build something. This is where the blueprints start to look like the real thing. And the QA/QC focus shifts from checking materials to checking workmanship. Every single weld, every alignment, every connection gets put under the microscope.
So how do you keep track of all those checks? With this right here, the Inspection and Test Plan, or ITP. This is the master script, the playbook for the entire quality process. It lists every single inspection, what standard to use, and who needs to be there. It's the roadmap to getting it right.
And the ITP has different levels of control. A hold point is a full stop. Seriously, work cannot go on until a QC inspector comes and signs it off. A witness point means the client wants to be there in person to see the test. And surveillance is more like a spot check, where inspectors can pop in and review things whenever they want. It's a tiered system of oversight. And here's where you see just how specific this gets. For a simple pipe spool, inspectors are checking dimensions down to the millimeter and making sure the weld prep is flawless. But for a high-speed pump, it's a whole different ballgame. It's all about perfect leveling and using lasers for alignment, because even a tiny misalignment could cause the whole thing to shake itself to pieces later on.
And now for the main event. Everything's been built, it's all installed, but does it actually work? Well, the testing and commissioning stage is the final exam. It's a series of tough, grueling tests that are designed to prove the system can handle real-world pressure safely and reliably.
So first up in this gauntlet, the thousands and thousands of feet of pipe that are like the veins and arteries of the whole plant. We have to be 100% sure there are zero hidden flaws and, of course, no leaks.
To check the pipes, we use what's called non-destructive testing, or NDT. Just think of radiographic and ultrasonic testing like X-rays or sonograms for the welds, letting us see tiny flaws the human eye could never catch. And then, the grand finale is the Hydra test. You fill the whole system with water, crank up the pressure, and prove it's absolutely leak-proof. It is the ultimate stress test.
Of course, it's not just about the pipes. Every single piece of equipment, pumps, air ducts, electrical switchgear, you name it, each one has its own unique set of trials it has to pass before it gets the final checkmark.
And the variety of tests is just wild. For rotating equipment like pumps, we're checking for the tiniest vibrations.
For the HVAC system, we're pressure testing massive air ducts to find leaks. For Substation, we're running incredibly complex tests on relays to make sure they'll protect the electrical grid. Every test is specifically designed for what that piece of equipment does.
So we've built it. We've tested it. Now comes the final, and you could argue the most important stage of all, creating the permanent record. Because in engineering, if you didn't document it, it might as well have never happened. This is where we gather all the evidence.
And this stage is a paper storm. You've got material inspection reports for everything that came in the gate. You have non-conformance reports for anything that didn't go according to plan. Punch lists track all the little fixes that still need to get done. And, this is so important, you have calibration certificates for every single testing tool, proving your measurements were accurate.
All of that paper, all of that evidence gets bundled into this, the QA/QC dossier. This isn't just a binder of reports, it's the project's entire life story. It tells the complete quality journey from day one, giving the client the final, undeniable proof that what they're getting is safe, reliable, and built exactly to spec. And this is how it all wraps up. That massive dossier gets put together, it's checked and double-checked internally, and then it's officially submitted to the client. They do their own deep dive, and once they're happy, they give the final sign-off. That's the moment the quality loop is officially closed. You know, this quote just sums it all up perfectly. This whole process, everything we've just walked through, it isn't about doing a few random checks. It's about building a consistent habit of doing things the right way and documenting every single step to prove it. So, I'll just leave you with this little thought. We demand this incredible level of proof and traceability for our bridges and power plants. What if we applied that same kind of rigor to the other complex systems we design, in our businesses, our communities, maybe even in our own lives? It's something to think about.